Now let's look at the domain of radical functions. We've talked about this a little bit already, but now we're going to look at the rules. A radical function is a function that can be described by a radical expression. To find the domain of radical functions, use the following guideline. If a function is given by a radical expression with an odd index, the domain is the set of all real numbers. You could either write the domain as negative infinity to positive infinity like this, or you could write it as a double-lined R, meaning x is an element of the real numbers. So your domain values can be anything from negative infinity to positive infinity. If a function is given by a radical expression with an even index, meaning 2, 4, 6, 8, etc., the domain is the set of replacements for which the radicand is non-negative. This would be from 0 to infinity if we had f of x is equal to the square root of x. The domain would be including 0 to positive infinity. You can't put numbers into the function that would make the radicand negative. So let's find the domain of the following functions. We do this by using an inequality. You would agree that x has to be greater than or equal to 0 in the statement I put in the box here. We'll do the same thing, but instead of the x, we'll put whatever radicand is in the even root or radical. So to find the domain of the square root of x minus 2, we'll take x minus 2 and say it must be greater than or equal to 0. Then we solve similar to a regular equation by adding 2 to both sides. And that gives us x is greater than or equal to 2. That is the domain of the function. We could also write this as the interval, open bracket, 2, comma, infinity, close parenthesis. If we have the square root of x plus 8, we need to take the radicand, x plus 8, and find what values will be positive by making an inequality once again. X plus 8 must be greater than or equal to 0. That means that if we subtract 8 from both sides, the function will remain positive if x is greater than or equal to negative 8. My domain interval would be open bracket, negative 8, comma, to infinity, close parenthesis. Now let's take a look at h of x equals the fourth root of x minus 9. X minus 9 is the radicand. So let's find out what values of x will keep the radicand positive. We know the radicand must be greater than or equal to 0. So if we solve for x by adding 9 to both sides, we see that x must be greater than or equal to 9 to make the domain or the radicand stay, let's say, non-negative. So the domain for this even radical function must be from 9 to positive infinity. So open bracket, 9, comma, infinity, close parenthesis. Let's take a look at these last three. G of t is equal to the sixth root of 4 minus 3t. We take the radicand, 4 minus 3t, and we say this must be greater than or equal to 0. If we isolate t, we can figure out what values of t will make the radicand stay positive. Let's first subtract 4 from both sides. This will give us negative 3t is greater than or equal to -4. Then let's divide by -3. Remember, with inequalities, if you divide by a negative, you have to flip your inequality over. So t must be less than or equal to 4/3. If we write this as an interval, we would say that this must exist from -infinity to 4/3. Now let's look at the cube root of x. X is in an odd index radical. So we know that x can be an element of the real numbers, or the domain is -infinity to infinity. Because it is an odd index, this is true. Finally, we have the square root of x squared plus 1. Now let's just double check this. I'm going to graph x squared plus 1. X squared is a parabola, and it's been shifted up 1. There is never any point in which x squared plus 1 has negative range values. It never crosses the x-axis. There are never any negative range values for the radicand. So, x squared plus 1 has no restrictions on it. Is always greater than or equal to 0. Notice that if we try and solve for the x coordinate here, we're going to get some interesting statement about imaginary solutions. So the only way you would get values that would cause problems is if you had imaginary numbers in your radicand. So x is an element of the reals once again,